November 12, 1942. Richmond, California. At the gates of Permanente Metals Corporation's second shipyard, a fully completed cargo ship stood poised to enter San Francisco Bay. Measuring 441 feet in length and weighing nearly 28.5 million pounds, the vessel represented something previously thought impossible. It had been built in just 4 days, 15 hours, and 29 minutes. For generations, shipbuilders had required 6 to 8 months to construct vessels of comparable size. That had been the standard since long before the American Revolution. Yet here stood a finished Liberty ship, ready for active service. More than 1,000 workers stepped back from the hull of the SS Robert E. Peary. They were not seasoned shipwrights or lifelong maritime craftsmen. They were former clerks, farmers, housewives, and laborers, people who had learned to weld only weeks earlier. Around them gathered government officials, journalists, and rival shipyard owners, all witnessing a moment that would permanently reshape industrial production in the United States. The outcome of the war, it was becoming clear, would not be decided solely by battlefield tactics. It would be decided by production figures, numbers that shattered long-held assumptions about shipbuilding limits, construction timelines, and what industrial systems could achieve. This transformation began on December 27, 1940, when Henry J. Kaiser signed his first shipbuilding contract. Kaiser had never built a ship, never managed a shipyard, and had spent most of his career moving earth and pouring concrete for massive dam projects across the American West. At 58 years old, he now promised the U.S. Maritime Commission that he would deliver 30 cargo ships for the British government within 2 years. Established shipbuilders dismissed him as an amateur chasing wartime profits. Todd Bath Iron Works, one of America's oldest shipyards, reluctantly agreed to partner with Kaiser, believing their expertise would compensate for his inexperience. What they failed to see was that Kaiser's ignorance of traditional shipbuilding would become his greatest strength. Watching closely was William Francis Gibbs, the nation's most respected naval architect. His firm, Gibbs & Cox, had designed the Liberty ships based on British models. Gibbs had designed more ships than Kaiser had likely ever stepped aboard. The shift from skepticism to revolution began in the planning offices of Todd Shipyards in New York. As Kaiser and his engineers studied standard shipbuilding procedures in early 1941, they reached a simple conclusion: traditional methods could never meet wartime demand. Kaiser's chief engineer, Clay Bedford, had recently toured a Ford Motor Company assembly line in Detroit. There, he watched automobiles move steadily down production lines as workers installed standardized components at fixed stations. Bedford returned to California convinced the same principles could be applied to ships. Traditional shipbuilders laughed at the idea. Then came Kaiser's most radical proposal, eliminating riveting altogether. Conventional ship construction relied on millions of heated metal rivets hammered through overlapping steel plates. Even the most efficient crews could install only about 100 rivets per day. A single Liberty ship required roughly 1 million rivets when built by traditional methods. Kaiser proposed replacing rivets with electric arc welding, a technique he had mastered while building pipelines. Vice Admiral Emory Land, head of the U.S. Maritime Commission, was deeply skeptical. Welding had never been proven reliable at this scale. The British Navy forbade its use on warship hulls. Kaiser was asking the Allies to risk their supply lines on an untested method. But Land also understood the stakes. German U-boats and surface raiders were sinking Allied ships faster than they could be replaced. In 1941 alone, more than 3.6 million tons of Allied shipping were lost. Britain was facing starvation. American shipyards, using conventional methods, needed an average of 230 days to build a single cargo ship. At that pace, the Battle of the Atlantic would be lost. Approving Kaiser's contract was not an act of confidence, it was an act of desperation. The Richmond shipyard rose from empty mudflats in 1941. Instead of the massive gantry cranes and long building ways typical of traditional yards, Kaiser built something entirely different. The facility was organized like an automobile factory. Large prefabrication zones surrounded 7 parallel building ways. Rail lines moved enormous steel sections across the yard, while overhead cranes capable of lifting entire ship sections stood every 100 feet. Veteran shipbuilders were appalled, and quietly impressed. To staff the yard, Kaiser recruited workers nationwide. He offered wages 20% above standard industrial rates and promised to train anyone willing to work. By October 1941, more than 10,000 people were employed in Richmond, fewer than 200 with any maritime background. Complex jobs were broken down into simple, repeatable tasks. Skills that once required years of apprenticeship were taught in weeks. Workers learned only what they needed: how to weld a specific seam, plate, or curve, and to repeat it over and over. As experience accumulated through late 1941 and early 1942, construction times dropped at a staggering pace. The first Liberty ship took 197 days to complete. The next took 169. Then 128. Then 97. By spring 1942, Richmond was delivering ships in an average of just 70 days. Traditional shipyards watched with growing alarm as this inexperienced workforce matched, and soon surpassed, their output. Prefabrication proved decisive. Ships were no longer built step by step from keel to deck. Entire sections, bows, sterns, engine rooms, deckhouses, were constructed simultaneously across the yard. When ready, cranes lifted the sections into place, where welding crews joined them together. Albert Wooding, production supervisor at Richmond Yard No. 2, explained the advantage in a 1943 interview. Traditional shipbuilding, he said, was sequential. One task could not begin until the previous was finished. Kaiser's system allowed parallel production. While one crew welded hull plates, another assembled engines in open workshops. When both were ready, the engine was lowered into place and welded in a single operation. Tasks that once took weeks now required hours. The numbers told the story. Where a conventional yard might assign 50 workers to install an engine over 3 weeks in a cramped hull, Kaiser assigned 200 workers to assemble the entire engine system in 5 days, then installed it in one 8-hour lift. Henry Kaiser had entered shipbuilding knowing nothing about it. In less than 3 years, he transformed how ships were built, and helped change the course of the war. Even more unsettling for traditional maritime authorities was how casually Kaiser discarded centuries-old shipbuilding rules. For generations, ships had been constructed strictly according to detailed blueprints that specified every rivet, plate, and joint. Kaiser replaced these exhaustive plans with simplified drawings that defined only basic dimensions, leaving many decisions to the judgment of workers on the ground. To conventional shipbuilders, this approach bordered on recklessness. Kaiser called it flexibility. Vice Admiral Howard Vickery, vice chairman of the U.S. Maritime Commission and a career naval officer, initially fought Kaiser's simplified specifications. His gradual shift from skeptic to supporter, recorded in commission meeting minutes, became a powerful example of results triumphing over theory. In January 1942, Vickery openly opposed reducing drawing detail, insisting that ships were not automobiles and that maritime construction demanded precision. By March, however, Kaiser's yards were outproducing traditional contractors by 40%. By June, the gap had grown to 70%. Vickery eventually conceded a hard truth: perfection was the enemy of sufficiency. Kaiser's ships were not elegant, but they were functional, and functional ships delivered cargo, while perfect ships still on the drawing board delivered nothing. As construction speeds accelerated through the spring and summer of 1942, rivalry emerged among Kaiser's 7 shipyards across California, Oregon, and Washington. Edgar Kaiser, Henry's son and vice president of the company, oversaw all operations, with particular attention to the 3 Pacific Northwest yards. He personally managed the Oregon Shipbuilding Corporation in Portland. Clay Bedford directed operations at the Richmond yards in California. Both men were driven and competitive, and an informal contest soon began, which yard could build ships faster. The race between Richmond and Portland became a public spectacle by the fall of 1942. Newspapers reported progress like sports scores. Records fell repeatedly, culminating in September when the Oregon yard completed the Joseph N. Teal in just 10 days. Vice Admiral Vickery eventually ordered the contests stopped, dismissing them as publicity stunts that risked distracting from sustained production. But by then, Kaiser had achieved his objective. Across all 7 yards, workers no longer viewed extraordinary speed as exceptional, it was now expected. November 1942 brought the ultimate demonstration. During a visit to Richmond, Vice Admiral Emory Land casually remarked to reporters that while Liberty ship construction had improved dramatically, recent speed records still paled compared to mass production achievements in other industries. Clay Bedford overheard the comment and took it as a challenge. Bedford proposed an audacious goal: Richmond Yard No. 2 would attempt to build and launch a complete Liberty ship in under 10 days, cutting the existing record in half. Land, skeptical but intrigued, approved the attempt on the condition that it not disrupt normal production schedules. The 47th hull assigned to Yard No. 2 was selected for the effort. It would be named SS Robert E. Peary, in honor of the Arctic explorer. At 1 minute past midnight on Sunday, November 8, more than 1,000 workers began the attempt, operating in carefully coordinated shifts. What followed marked the ultimate expression of prefabrication. Before the keel ever touched the building way, every major component had already been built, inspected, and staged. The bow section, more than 50 individual pieces, was fully welded and equipped with anchors, chain lockers, and forward crew quarters. The stern section arrived complete with steering gear, propeller shaft, and aft living spaces. For massive cargo holds stood ready to be lifted into position. The engine, a 140-ton triple-expansion steam plant built by Joshua Hendy Iron Works in Sunnyvale, had been fully assembled, mounted on its foundation, and tested before leaving the factory. Where traditional shipyards built ships step by step over many months, Kaiser's yards assembled an almost complete vessel from prefabricated sections in days. For days after construction began, the hull was complete. The engine was installed. Deckhouses were positioned. Cargo holds secured. Steering gear mounted. On Thursday afternoon, November 12, just 4 days, 15 hours, and 29 minutes after keel laying, the SS Robert E. Peary slid down the ways into San Francisco Bay. The ship entered service on November 15, setting another record, just over 7 days from keel laying to full delivery. The launch drew maritime officials, military officers, rival shipyard owners, and journalists from across the country. Many expected to witness either failure or a barely functional shell. Instead, they saw a fully operational ship requiring only minor finishing work. Vice Admiral Land, present at the launch, addressed the crowd briefly. His remarks, captured by newsreel cameras, signaled the maritime establishment's reluctant acceptance that everything had changed. 6 months earlier, he admitted, such an achievement would have been dismissed as impossible. 3,000 years of shipbuilding wisdom had insisted that a proper ship could not be built in days. Henry Kaiser had made that wisdom obsolete. The Maritime Commission soon mandated that all contracted shipyards adopt Kaiser's methods. The impact on traditional builders was immediate and profound. Yards that had mocked Kaiser as an outsider only 18 months earlier now sent engineers to study his operations. In December 1942, the president of New York Shipbuilding Corporation, one of America's oldest and most prestigious yards, visited Richmond. His confidential report to the board revealed a complete collapse of traditional thinking. Kaiser, he wrote, had succeeded by rejecting long-accepted limitations. He treated shipbuilding as a manufacturing problem, not a craft tradition. He simplified where others sought perfection, standardized where they customized, and trained masses of unskilled workers where the industry had relied on generational expertise. The result was ships built in 1/10 the time at 2/3 the cost. The conclusion was unavoidable: adopt Kaiser's methods or become irrelevant. By early 1943, Kaiser's influence had reshaped American maritime production. 18 shipyards nationwide were building Liberty ships using prefabrication and welding. Average construction time fell from 230 days to just 42. The United States was now launching 3 Liberty ships per day, more tonnage than German submarines could sink. Perhaps the most unsettling consequence for traditional authorities, however, was the workforce itself. Tens of thousands of women, minorities, and previously untrained laborers had built these ships, directly challenging the old guild system that had dominated shipbuilding for centuries. At peak production in 1944, Kaiser's 7 yards employed nearly 196,000 workers. More than 40,000 were women. By mid-1944, women made up 27% of Richmond's production workforce, while the Northwest yards alone employed over 31,000 women. African American workers numbered in the tens of thousands, filling skilled roles in welding, fitting, crane operation, and even supervision, an extraordinary level of workplace integration for 1940s America. By proving that complex manufacturing could be mastered through training rather than inherited craft, Kaiser's shipyards reshaped ideas about labor, skill, and industrial organization. Christmas 1943 offered a final glimpse of this new industrial culture. While traditional yards shut down for the holiday, Kaiser's facilities maintained production, but paired it with recognition. At Richmond, workers on shift were served full Christmas dinners in the cafeterias at no cost. Local churches sent carolers. The municipal band performed. It was not just mass production. It was mass mobilization. Kaiser personally visited his shipyards, shaking hands with workers and thanking them for their service. By mid-1944, his 7 yards had already produced more than 800 Liberty ships. Yet the impact of his methods extended far beyond his own facilities. Across the United States, 18 shipyards building Liberty ships had collectively delivered around 2,400 vessels by that point. From 1944 onward, production was supplemented by Victory ships, larger and faster, but constructed using the same principles of prefabrication, welding, and modular assembly. Between 1941 and 1945, American shipyards produced more than 5,500 vessels with a total displacement of approximately 53 million tons. The scale of this effort astonished contemporaries and remains remarkable even by modern standards. Commander Joseph Kenworthy of the Royal Navy, assigned to the British Admiralty mission in Washington, observed American production with a mixture of admiration and envy. In reports later declassified in the 1980s, he captured the British perspective on America's industrial dominance. The United States, he noted, was building merchant shipping at a rate exceeding the combined output of the rest of the world. Kaiser alone produced more tonnage each month than the entire British shipbuilding industry. By British naval standards, the American methods appeared crude. The ships were inelegant, but they floated, carried cargo, and, most importantly, there were thousands of them. The Royal Navy built the finest warships in the world using traditional craftsmanship that required years per vessel. The Americans, by contrast, built ships that were good enough in a matter of weeks. Adequate, multiplied by thousands, proved more decisive than perfection multiplied by dozens. After the war, many analysts predicted that the shipbuilding boom would collapse, leaving tens of thousands unemployed and vast industrial complexes abandoned. In part, those predictions came true. Liberty ship production ended in September 1945, and by December Kaiser's workforce had fallen from 200,000 to fewer than 20,000. The Richmond shipyards, which had employed up to 100,000 workers at their peak, stood largely empty by the spring of 1946. Yet the knowledge gained during the emergency program did not disappear. The prefabrication methods, welding techniques, and parallel production processes pioneered by Kaiser became standard practice in global shipbuilding. When Japan and South Korea rebuilt their maritime industries in the 1950s and 1960s, they closely studied the Liberty Ship program and adopted its principles as the foundation of their own yards. The massive shipbuilding complexes in Ulsan, South Korea, and Nagasaki, Japan, which would dominate global ship construction for decades, were direct descendants of the revolutionary practices first implemented in Richmond. Maritime historian John Bunker summarized Kaiser's lasting influence in his definitive 1972 study. Kaiser entered shipbuilding as an outsider, unconstrained by maritime tradition and willing to apply industrial manufacturing principles that the established industry considered unsuitable for ship construction. In just 36 months, he built more ships than had been constructed in the United States during the entire previous century. More importantly, he fundamentally transformed how ships would be built worldwide for the rest of the 20th century. Modular construction, large-scale prefabrication, and welded assembly, once controversial, are now universal standards. Every modern shipyard, whether producing container vessels in Korea, oil tankers in Japan, or cruise ships in Europe, relies on approaches derived from Kaiser's Liberty Ship program. The magnitude of this achievement is reflected in the statistics. Between 1941 and 1945, 2,710 Liberty ships were built across 18 American shipyards, with peak production averaging nearly 2 ships per day. Kaiser's 7 yards alone produced 1,490 vessels, accounting for 27% of all American wartime merchant shipping built under maritime commission contracts. Construction time dropped dramatically, from an average of 230 days for the first Liberty ships in 1941 to just 42 days by 1943. The record was set by the Robert E. Peary, launched only 4 days and 15 hours after its keel was laid. Labor efficiency improved just as sharply. Early ships required about 1 million worker hours, while by 1943 the average had fallen below 500,000. Kaiser's most efficient yards reduced this figure to as few as 350,000 worker hours through continuous 3-shift, 24-hour production and maximum prefabrication. Costs followed the same downward trend. The first Liberty ships cost between $1.75 and $2 million each. By 1943, the price had fallen to roughly $1.8 million, despite rising wages and material costs. Each vessel displaced over 14,000 tons when fully loaded and could carry more than 10,000 tons of cargo, including thousands of vehicles, hundreds of tanks, or hundreds of millions of rounds of ammunition. Although powered by deliberately old-fashioned triple-expansion steam engines, the ships were reliable and easy to manufacture. Their speed of 11 knots was sufficient for convoy operations. Training efficiency was equally remarkable. Kaiser's schools prepared workers for specific tasks in an average of just 2 weeks, with some welders becoming productive in as little as 10 days. This stood in stark contrast to traditional maritime apprenticeships that required years to achieve basic competence. Combat losses demonstrated that speed did not come at the expense of effectiveness. Of the 2,710 Liberty ships built, roughly 200 were lost to enemy action, a loss rate of about 7.4%, comparable to or better than pre-war merchant shipping. Early structural failures led to improved welding techniques and steel standards, eliminating most problems by 1944. Designed as emergency vessels with an expected service life of only 5 years, Liberty ships proved far more durable than anticipated. Many remained in service for decades after the war. Some survive to this day, serving as museum ships and sailing memorials, enduring proof that a program built for speed reshaped shipbuilding for generations. Many Liberty ships were sold to foreign shipping companies and continued operating well into the 1970s. One vessel, however, followed a particularly unusual path. The SS Albert M. Bow, the final Liberty ship built and delivered on October 30, 1945, was not scrapped. Instead, it was sold in 1964 for just $65,557 and converted the following year into a fish cannery ship named Star of Kodiak. Today, more than 8 decades after its construction, it still exists as the landlocked headquarters of Trident Seafoods in Kodiak, Alaska. The economic impact of the Liberty Ship program extended far beyond shipbuilding itself. The enormous demand for steel drove a rapid expansion of American steelmaking capacity, especially on the West Coast. To supply his shipyards, Kaiser constructed the Fontana Steel Mill in California. Completed in 1942, 5 months ahead of schedule, the mill produced roughly 700,000 tons of steel annually and established California as a major steel-producing region for the first time. Other critical materials followed the same pattern. Magnesium for incendiary munitions and aluminum for aircraft were produced in Kaiser-owned plants built as part of an integrated wartime production system. The employment effects rippled across entire regions. Communities throughout California, Oregon, and Washington were transformed almost overnight. Richmond, California, grew from a population of just 23,000 in 1940 to more than 100,000 by 1943. In Oregon, Kaiser went so far as to build an entirely new city. Vanport City, created solely to house shipyard workers, briefly became the state's second-largest city, with a population exceeding 40,000. Nearly all its residents worked either in shipyards or in industries that supported them. Though temporary, these boom towns demonstrated the profound impact that concentrated industrial investment could have on society. One of the most unexpected legacies of the shipbuilding program emerged in healthcare. To care for his massive workforce, Kaiser partnered with physician Sidney Garfield to create prepaid medical programs for shipyard workers. These initiatives eventually evolved into Kaiser Permanente, one of the largest health maintenance organizations in the United States. The model of prepaid, preventive healthcare pioneered in the shipyards influenced American medical practice for decades and served more than 12 million members by the early 21st century. The workers themselves carried the program's lessons into peacetime life. For thousands of people, especially women and minorities, the shipyards provided opportunities that traditional career paths had never offered. Skills learned under wartime pressure opened doors that remained open for the rest of their lives. Technological innovations from the Liberty Ship program spread far beyond maritime construction. Welding techniques refined during the war became standard in structural steel fabrication, petroleum refining equipment, and pressure vessel manufacturing. Prefabrication methods developed at Richmond influenced housing construction, bridge building, and industrial facilities. Organizational principles such as parallel production, simplified specifications, and rapid task-focused training became foundational concepts in operations management and industrial engineering. In a 1985 study on American industrial competitiveness, Harvard Business School professor Michael Porter identified the Liberty Ship program as a landmark example of rapid capability development. Kaiser demonstrated that industrial capacity is not fixed, it can be created quickly when necessity demands it. The United States entered World War II with minimal merchant shipbuilding capability. Within 24 months, American yards were producing more shipping tonnage than the rest of the world combined. This achievement revealed a deeper truth. Limits on industrial capacity often reflect organizational assumptions rather than physical constraints. The psychological transformation brought about by the Liberty Ship program proved as important as the ships themselves. Before Kaiser, manufacturing leaders largely accepted traditional beliefs about production limits, skill requirements, and organizational structure. Kaiser showed that those beliefs could be wrong, and that breakthrough performance required questioning fundamental assumptions. The Liberty Ship story stands as a testament to human potential and industrial possibility. The ships mattered, but what their construction proved mattered even more. Ordinary people, given training, trust, and opportunity, achieved extraordinary results. Products that once required years of craft tradition were manufactured in weeks through systematized processes. Industries resistant to change for centuries were transformed in a matter of months when innovation met necessity. Admiral Chester Nimitz, commander of the U.S. Pacific Fleet, later reflected on the strategic consequences of American maritime production. In his post-war memoirs, he wrote that the war across the vast Pacific was sustained by ships built faster than the enemy could sink them. Japanese planners believed American industrial capacity was impressive but finite. They assumed that sinking enough ships would eventually cripple American logistics. They failed to account for Henry Kaiser. By 1944, American shipyards were replacing losses faster than the enemy could inflict them. The mathematics of attrition favored the side that could build 3 ships per day over the side that could sink 2. Industrial capacity, not battlefield heroism alone, determined the outcome. The war was won not only on distant beaches, but in the shipyards of Richmond, Portland, and Baltimore. In the end, Kaiser's greatest achievement was not the 1,490 ships built by his yards, but the transformation of what industry believed possible. The Robert E. Peary, completed in less than 5 days, stood as proof that tradition does not equal truth, that accepted limits can be challenged, and that revolutionary results require revolutionary thinking. The maritime establishment that dismissed Kaiser as an ignorant outsider in 1940 spent decades after the war studying and adopting his methods. The workers who learned to weld, fabricate, and assemble carried those skills into peacetime industries that rebuilt the American economy. Techniques developed under wartime urgency became global peacetime standards. The Liberty ships themselves are mostly gone now, scrapped long ago or resting on the ocean floor. But the revolution they represented endures, in every modern shipyard, in every factory that relies on prefabrication, in every training system focused on rapid skill development, and in every manager willing to question whether impossible truly means impossible, or simply that no one has yet figured out how. That is Henry Kaiser's lasting legacy. Not steel ships, but a transformed understanding of what ordinary people can accomplish when freed from tradition and organized to attempt what experts insist cannot be done.